Okay, so today we're working on unit 10.6. Okay, this is going to be the last set of notes for this unit. We are testing on Friday. Okay, and this is just probability review. Okay, probability review. First thing we did with probability was called the fundamental counting principle. Okay, fundamental accounting principle. The fundamental accounting principle is when you take, that's with the spaces, okay, and you want to write the number of choices, and you're going to write the spaces and multiply by number of choices, okay. It's when you have multiple choices, okay, and you multiply them all together. There's not a certain amount of spaces that you're going to be multiplying, okay. You just take the number of choices and multiply them together. You want to use this when logic seems best. Okay, so use when you think logic seems best.
Why?
Use this when logic seems best. Okay, you want to use the fundamental counting principle as much as you possibly can because it's the easiest type of probability to find. Okay, so use this when logic seems best. Next thing we went over was factorial. Okay, factorial is that exclamation point, and factorial is when you multiply all whole positive integers lower together. So, for example, if I asked you to find 6 factorial, 6 factorial is really 6 times 5, 4, 3, 2, and 1. You could do that on the calculator, okay? It's totally fine to use a calculator, but factorial is just when you take every whole number lower and multiply them together. Next thing we went over were permutations. Permutations, okay? Permutations. You are supposed to use permutations when order does matter. Okay? When order does matter. Okay, so sometimes when order does matter would be in a race. So determine how many different ways there are to finish first, second, and third, that type of stuff. Okay, races, identification numbers. So things like phone numbers, social security numbers, stuff like that. Okay, when order does matter. The formula that you do have to have memorized for permutations, it's not enough to just know how to put it on your calculator. There is going to be a question that specifically just asks, what is the formula for a permutation? Okay, which one is written correctly? It's one of the multiple choice. And NPR is equal to n factorial divided by the difference n minus r factorial. Guys, stop, please. N factorial divided by n minus r factorial. Okay, those are for permutations. Next thing we went over was spelling. Okay, and whenever you're dealing with spelling, you take the total number of letters, factorial, divided by each repeat, factorial. So if you're figuring out how many different ways can these letters be arranged, you take the total number of letters, factorial, divided by each repeat, factorial. Okay? So what you're going to be able to do today is you're going to do a worksheet. It's kind of like a review, and this is going to have all the different types of probability on it that you could possibly see. Okay, so you're going to want to study the notes for today just so you know those are all the different kinds of formulas.
Are these the notes for today? No.
Next thing we went over was combinations. Okay. Combinations, you'd use a combination when order does not matter. When order does not matter. And most of the time when order does not matter, it's going to be when you're dealing with a committee. Okay, so when you're dealing with committees. You also have to have the formula for NCR memorized. Okay, and the formula for NCR is equal to n factorial divided by r factorial multiplied by the difference n minus r factorial. Okay, you do have to have these memorized and know which one is which. Okay, it's not enough to just know how to put them on your calculator. Yes?
Why is there a C in the equation?
Combination? That
Well, I
stands for
guess that
combination.
makes sense, and permutation.
Permutation has a P, yes.
I'm stupid.
Yep.
Can you go back to the conversation?
Do you have to know the difference between combination and permutation? We still have one more page. Are we done? Okay. So these are all different things these are all the different kinds of formulas that you would use when you're trying to figure out how many different options are there, okay? Then we went into actually probability. Anytime you see the word probability in your question, you need to be thinking that your answer is going to look like what? It's going to be in what kind of version? A fraction, okay? It's either going to be a fraction or a decimal, okay? So probability is always defined as the outcome that you want, so what you want, divided by total possible outcomes. So how many favorable outcomes or what you want divided by the total possible outcomes. So how many different possible things could happen? Sam, why aren't you taking it? Write it down. What you want divided by total possible. You also need to know the probability of something not happening. And the probability of something not happening is equal to 1 minus the probability that something will happen. Okay, those are called complements to each other. So the probability of it not raining is 1 minus the probability that it would rain. Okay, so 1 minus whatever the probability is. Something will happen. Probability of something not happening is equal to 1 minus the probability that it will happen.
Or you can just make sure that they all use 100%.
That's what you're doing.
Yeah.
That's what this does. Okay. You also need to know how to find probability of overlapping events. Okay, so overlapping events. This is when you're picking one thing. Okay. Overlapping events. The formula is the probability of A or B happening is equal to probability of A plus the probability of B minus the probability of A and B. So if you're thinking, if you want to know what's the probability of one thing happening, so for instance, what's the probability that I picked one student's name out of this class, it would be a sophomore or a boy. You have to add together all the sophomores, plus you have to add together all the boys, but then subtract, there's a lot of people that are both, okay? Like Jalen is both, so I double counted him here, okay? You have to subtract out the ones that you double counted, so that's called overlapping events. Okay, I also want to make sure that you know the difference between independent and dependent events. An independent event is when the results are not affected by one another. The results are not affected by one another. Okay, so the result of one thing happening does not affect what happens next. So independent events are with replacement. So if you take something out and put it back, it's not going to affect the next thing happening. Okay, those are considered with replacement events. Completely opposite of that is a dependent event. And a dependent event is when the result of one event does affect another. Okay, so the result of a dependent event, is affected by another, and that is without replacement. If you don't replace something, you have less to choose from in the next option. I also want to make sure you remember, anytime you see the word and, what does that tell you to do? And means multiply. The word or implies that you should add. Okay, and means multiply, or means add. And then last thing we did for this unit was conditional probability. Okay, and conditional probability is the influence of one event on another. The influence of one event on another. This one does also have a formula, and you need to know that the probability of B given A, okay, so that line means given, is equal to the probability of being both A and B divided by, if you're just picking from the first one. So B given A is equal to the probability of both divided by just, if you're just picking from the first one. Okay, those are all the different concepts and formulas that we did for this whole unit. Every single one. So that's going to be, you're going to be working on your worksheet today. You're doing worksheet number 6. You're actually doing 1 through 24. I apologize, it says 23 on the board, but it should be 1 through 24. Okay, worksheet 6, number 1 through 24. And that's it.